Okay, students, this simulation is about the spontaneous and random nature of the radioactive decay process. We will see that in this simulation that if we have certain number of radioactive nuclei at the start, and those number of nuclei will decay spontaneously and randomly. In the black box, which is in front of you, this box will be filled with a certain number of radioactive nuclei, and you will see you can realize that those radioactive nuclei will be decaying randomly and spontaneously, right? At the start, you will see that the number of nuclei will be decaying at the faster rate, and then with the passage of time, the rate of decay will be becoming smaller and smaller. So let's just start the simulation. We can start, let's say, with 1000. You can say number of radioactive nuclei, and then we press the button in which I have labeled the text initialize, and the nature lets radioactive nuclei decay spontaneously and randomly. Okay, so we can click it. You can see that at the start, the black box is filled with reddish color. You can say the radioactive nuclei will decay with the passage of time. So reddish, you can say the circles represent the number of undecayed nuclei, and the white circles represent those nuclei which have decayed with the passage of time. So from the graph, you can see that at the start, the number of nuclei are decaying at the faster rate, because at the start there are, you can say, larger number of undecayed number of nuclei. So that's why the rate of decay at the start, that the slope of the graph is greater as compared to the slope or the gradient of the graph at later times. Okay. So again, we can check it again. Let's say there are 2000. Let's say 2000 nuclei. In that case, you can see here the, you can say, slope of the graph at the start will be greater as compared with the previous one. Okay, so it will be following the same, you can say, structure of for the decay, but the difference is that the slope will be greater as compared with previous graph, because for the 2000 number of nuclei present at time t is equal to 0, there are greater number of nuclei present at any time t as compared with the previous graph of nuclei. Okay, so you can repeat the simulation for another number of nuclei again and again, and you can see that the number of nuclei, you can say, decrease with the passage of time like this, as shown by the graphs. Okay, thank you.